One of the most recognizable tastes and smells is citrus. Whether it's a lemon, a lime, an orange, or any other common citrus fruit, a lot of us enjoy eating them, drinking them, and putting them in our food. So I want to talk to you guys today about the chemistry of lemons and oranges, mainly lemons. And so we can learn some new things that maybe you didn't know. Okay, so the first thing that I think about, and I think a lot of us might think about, is the taste. Okay, and the most common taste, at least when I think about these things, is sour. So where does sour come from? Sour is actually citric acid, and citric acid is this guy right here. Citric acid is about 5 to 6% by weight in lemon juice. The other compound that contributes to the sourness of lemons and other citrus fruits is malic acid. A lot less common, but still contributing to that sour flavor that you experience when you will eat a lemon. The next thing I like to think about when it comes to lemons is the smell. If I could draw a nose, I would draw a nose. I do not know how to draw a nose, right? Right, just pretend there's a nice nose there. Okay, the smell. So the smell is very interesting. Okay, so the smell of citrus fruits, specifically lemons and oranges, is from a compound called limonene. And limonene is a terpene. I'm going to make a video on terpenes, but terpenes are the organic molecules that we find in fruits, vegetables, flowers that give a lot of these things we eat, smell, their smell. They're volatile compounds that are released into the air, and it's what we smell. So those are terpenes. Limonene is a terpene that gives lemons its smell and some of its flavor, but specifically that nice sharp smell. And there's two forms of limonene. For all of my organic chemistry buffs, we have the R and the S isomer. I will make a video on chirality, but basically this R and this S is telling us that light, when we shine light through this molecule, at certain points it'll turn light in a direction. Here, if we shine light through this molecule, or photons, plain polarized light, it will turn right. If we shine it at this one, it'll turn left. That's not important right now, but what is important is that slight turn in the bond gives it a different property. R-limonene is what gives orange its smell. S-limonene what gives lemons its smell. Limonene is also a common terpene in the cannabis plant, and its medicinal properties have been studied, and we'll go to our third category, which is medicine. I'm gonna move. Its properties have been heavily studied because of its involvement in the cannabis plant, and it gives the cannabis plant some of its smell and its taste. It comes across as very citrusy and sharp. But specifically what scientists have found, not just with cannabis, but in general with limonene, is it's antifungal, it's antibacterial, and its mood enhancing properties. And this mood enhancing property is, a lot of it is has to do with its involvement in cannabis. But as we can see, this terpene, it's very, very good for you. Another medicinal factor in lemons is good old vitamin C. I'm gonna draw vitamin C out for you guys. We have all been told we gotta get our vitamin C, but why? Why is vitamin C so important? So we know lemons, vitamin C is in lemons and a lot of citrus fruits. I want to talk about two things with vitamin C. One, what happens when you are deficient in vitamin C? And then two, what does it do in the body? When you have a vitamin C deficiency, it is called scurvy. We hear that word a lot with these pirates will go out to sea and they wouldn't get their fruits, and so they'd get scurvy. And scurvy presents itself as weakness in the body, sore arms, legs, poor wound healing, and a high infection rate. And so it's important that we don't have scurvy, which is why we need vitamin C. I'd love to go deeper into the mechanisms, but that's not this video. So what does vitamin C do in the body? It's understood that this guy right here is actually what's called, it among many things, I want to focus on one thing. It's called a when you ingest vitamin C, it is a catecholamine cofactor. So what does this long, complicated word mean? Catecholamine is basically the compounds epinephrine, norepinephrine, and others that run through our minds, run through our brains every single day, that balance our mood and our function as human beings. So catecholamines are very important. Dopamine, right? This is the molecule that makes us, one of the molecules that makes us happy, right? So catecholamines are very, very important. A cofactor is just a molecule that helps a reaction occur, right? It helps a reaction go faster. So basically, vitamin C allows for the body to make more neurotransmitters. In other words, epinephrine, norepinephrine, dopamine. That's the very, very basic definition. I want to draw a little picture out. Okay, where does this happen? Turns out that catecholamines are made in our kidneys on these little hats, I like to call them hats, called the adrenal glands. And this is basically like the factory for the catecholamines. This is where they're made, all right? They're made here, then they're pumped through the kidney, and this is where they get in the bloodstream and everything like that, right? So going back, right, to vitamin C, this is why vitamin C is so important. It's necessary for our bodies to make these chemicals that regulate our mood and our life, and it's necessary for our health. It has compounds that are antifungal, antibacterial, antibacterial, they're mood enhancing. We know citrus is sour, and now we can understand just some of the chemistry in lemons, but in general, common citrus fruits. I hope this was helpful. I hope that this made sense. If you guys would love any other videos, please comment and let me know. I'm here to just have fun and just show how chemistry can be involved in every single day life. That's the chemistry of citrus fruits, specifically lemons. Gonna have some more videos coming up later.